Good morning, students. Today's session we'll be learning regarding the laboratory program 3 under the data structure with C laboratory. So the laboratory program 3 is based on the stack. So before we go directly to the program, let us see the concept of stack. So first I'll take an example of arranging a textbook in a rack. So let us keep a textbook of let us keep a DS textbook. Above that, let us keep AD. Then let us keep CO textbook, and then we'll keep DMS. Okay, DMS textbook. So these are the textbooks which are arranged in a rack in a table. So what will happen? You have inserted the first textbook is DS. First textbook is DS. Above that AD. Above that CO, and then you have inserted the DMS. Now, what you have inserted first is DS, AD, CO, then DMS. Now, if I want to remove the textbook, which textbook should be removed first? Which textbook should be removed first? So that is nothing but I need to remove the DMS textbook first. Then comes with CO, and then with AD, and then finally is DS. For example, if I want to fetch the DS textbook, then I need to remove this DMS, then CO, then AD, then DS. So what you have observed here, DS was the textbook which was inserted first, okay, and this was the textbook which was removed last. It was inserted first and it was removed last. Okay, inserted first and it was removed last. So you can see, if you want to remove the DMS textbook, in this, so which will be removed? DMS textbook will be removed first, correct? Removed first, but this is inserted last. So this is inserted last. So if you remember this concept, then the definition of stack is clear. If you remember this concept, then the definition of the concept is clear. So let us see the definition now. Stack is an ordered list in which insertion and deletion can be performed at only one end, and that is called top. So here insertion and deletion takes place at only one end, that is called top. So here you can see this was removed first, this was inserted last. The other name for the stack is last in, first out. Again, stacks are sometimes called as last in, first out list. That is, element which is inserted first in the stack will be deleted last from the stack. So I have told you, see, DS was inserted first, but it is removed last. Here it was inserted last, removed first. So other name is last in, first out. Other name for the stack is last in, first out. So it is a recursive data structure having the pointer to its top element. So over here, initially if only the one textbook was the DS, then top would be pointing over here, only over here. Now 4 textbooks are there, so the top will be now pointing over here. Okay, so this is regarding the definition of the stack. So stack is nothing but it is an ordered list in which insertion and deletion can be performed at only one end, and that is called the top. And it's also a recursive data structure having pointer to its top of the element. So other than this DX textbook, I'll just give an example. So this is a structure of the stack. Okay, let us store around 5 element. So in this program we'll be doing array implementation. Okay, we'll be doing array implementation. It can be here, for example, this is a one second. Here it is in this way. So initially, if there is no element in the stack, okay, in case if there is no element, if stack is empty, then top is actually, we don't have any element, so top is -1. Since array, we are doing stack in array implementation, you know, indexing will start from 0, 1, 2, 3, 4. This array size is 5, but you know indexing starts from 0, 1, 2, 3, so you have 1, 2, 3, 4, 5. Now in case if I want to insert an element 10, okay, insert an element 10, then I inserted an element over here. I push the element from this way and it comes and sits out particular this location. I've inserted 10. Now top will get incremented and it will be pointing over here, top. So if stack is empty, top is equal to -1. If it contains only one element, then top is 0. You know, here it's only one element, then top is 0. Now let us insert, for example, we'll define a max size of a stack. Let it be a stack of 5, array of 5. We'll define array of 5. So you know the max size for this is 0, 1, 2, 3, 4, because only 5 elements it should store. Let it be like max arrays of only sizes of only 5. Okay, arrays, let us do like int stack 5. So what is happening, only 5 elements can be stored. So we'll push next element, that is 20. I'll push like 10, 20, 30, 40, 50. Okay, next again when I push 20, again the top will be incremented and it is pointing over here. So it is top is nothing but it is a pointer which will be pointing to the top element in the stack. So here the top element is 20. Next I want to insert 30. So the stack top value is 2. Next I want to insert 40. Now stack top value is 3. Next I want to insert 50. Now stack value is 4. The element in the particular stack of 4, the element will be stored is nothing but the 50. Here the element is 50. Now entire your stack is what? Now your stack is full, actually. Stack is full. So again, when you insert, right, next element, insertion is not possible because we have defined the size as only 5. So only 5 elements can be inserted. So when your status reaches to n, okay, when your status reaches to n, then it is a overflow condition. That means in case if it reaches to 5, I cannot insert any element. That is, n is nothing but 5. I have defined my stack size as 5. When it reaches this 5, the state is nothing but overflow. When it is reaching n-1, what is happening? n-1 is nothing but our stack we defined was 5. When n-1 is nothing but 4. When it reaches 4, what is happening here? Our stack is full. Condition is stack is full. Okay, so these are the things you need to remember. When stack is empty, top is always equal to -1 because no elements in the stack. When you have one element, top will be equal to 0. And when the status is n-1, your max defined size -1, then stack is full. When you have n, this is the condition where overflow reaches, because you cannot insert the element more than 5. You might get confused here. N is 5, but here 5 elements, but you know in array indexing starts from 0. So when it comes only till 4 we can insert. So n-1 only till 4 since stack size is 5. So stack is full. And then n condition is for the overflow. So this is the basic definition of the stack. It's an ordered list in which insertion and deletion can be performed only at the one end and is called top. It can be also implemented by using structure linked list, but in this program we are implementing using the array. So when you implement using an array, we should have a fixed size, or it may have a dynamic resizing. Okay, so that is based on the implementation of the array. Next, let us see the basic operations on the stack. So there are mainly two operations, that is push and pop. Push is nothing but pushing an element onto the stack. Push is nothing but pushing an element onto the stack. Pop is removing an element from the stack. Okay, so when you do these operations, push and pop, you will be seeing this peak, is full and is empty conditions. Okay, you'll be seeing is full, is peak, and is full and is empty. I'll be explaining these concepts over here itself. I'll be explaining the concept based over here itself. So I'll just tell regarding the push operation first. So what it does is, push operation is, first let us see regarding this. As I told, let us try to insert 10, 20, 30. So what it does is, initially your top is nothing is there, so top is -1. So it is not being pointed. First, in the push operation, it checks whether your stack is full. Why? For example, let us take the previous itself, 40 and 50. Okay, so you had 10, 20, 30, 40 and You had like this 10, 20, 30, 40 and 50. Okay, 10, 20, 30 and 40. So indexing was like 0, 1, 2, 3, 4. Okay, 0, 1, 2, 3, 4. Over here, let us keep this particular thing push. When you while you do the push operation, you need to perform 5 steps. Okay, tell the step in push. First step is you will check whether stack is full. First condition is check whether stack is full. Check whether stack is full. We'll check whether stack is full. Now in this state, our max size of array stack was like only 5 max. So you know it is only 5 elements can be filled over here. So whether stack is full, yes, check our stack is full. If stack is full, if the stack is full, you need to tell that you need to print a statement that stack is full, or like if you need to produce an error or exit from this statement. So stack is full. Otherwise, if this stack is not full, for example here, let us try over here. Okay, let the first element be here. Your 0 top is 0 now. Let the top is pointing over here. Indexing is 0, 1, 2, 3, 4. Okay, let the first element be there. In case if this is the state, then this and your max size was 5, then your stack is full and it will print up that stack is full and it will come out of this particular loop in the push operation. If not that, next step it will be performed if stack is not full. For example, you imagine that only first 10 has been inserted and the pointer index value is 0 and the pointer is pointing to the top is pointing to this particular position. Next elements I need to be array sizes, I mean these elements are empty and only one element, max size is 5 you're defined. Okay, if this is not empty, then if stack is not full, increment the top to point the next empty space. That is, next step is what? If stack is not full, increment the top. First to increment the top is equal to top plus 1, increment the top. Okay, so the top will be pointing over here now, and then on top of that stack top, you insert your element. For example, our element to be read is 20. So on that stack top, now this is a stack, right? Stack of 0, stack of 1. Over here, insert this particular element, 20 element, whatever the element is there. And then return the success. So this is how you are going to add the data element to the stack location where top is being pointed. So this is how the push operation takes place. So it has only two things to be checked. One, whether it is full. If it is not full, how can you do the insertion into the stack? How can you insert an element into the stack? One, you're going to check whether it is full. If it is full, you print up the statement that stack is full. If it is not full, come to the insert. In insert, you have 2 things to do. One, you increment the top, that is top is equal to top plus 1, and then you insert on the top of that stack top, you insert the element. So these 2 things you have to do. So for example, I want to insert 30, 40, 50. Same way, next again you increment the top first, so top will be pointing over here, then you insert the element. Next again I want to insert 40, increment the top, so what will be top is equal to top plus 1, so it will come and point over here, top, then it will be 40. Next again come to this particular location, 50 I want to insert, 50, then top plus 1, so again top will be pointed, then data element will be inserted. Next again if you want to insert 60, your size is 5, that is it is already reached n minus 1, your max size is 5, right? N is equal to 5, it's already reached n minus 1. Now when it comes to n equal to 5, and if you want to insert 60, stack will be going to full and you cannot insert further. That is what is the condition of the push operation. So this is regarding the stack push operation. So over here you check if stack is full, you're going to check this particular status in the push operation. Okay, next is regarding the pop operation. So what is happening in the pop operation? So next is regarding the pop operation. So over here, so let us see, like 1 second. So next is regarding the pop operation. So what is happening in the pop operation is you add the element 40 and 50. Pop is removing an element from the stack. Okay, removing an element from the stack. So over here in an array implementation of pop operation, the data element is actually not remote. Okay, instead top is decremented to a lower position in the stack to point to the next value. So over here, first step, what it does is it checks if the stack is empty. Why it needs to check if the stack is empty? If stack is empty, then you cannot pop any elements. So in the pop, you're going to check two things. First, stack is empty. First itself, you're checking if stack is empty. If stack is empty, what will happen? You cannot pop any elements. Okay, so it will come out of the loop. If not, stack is not empty. That means if it has a contents, if the stack is not empty, then it decreases the value of the top by 1. It decreases the value of the top by 1. That is nothing but top is equal to top minus 1. That's it. Top is equal to top minus 1. And if you want which element, for example, I want to remove this 50. Okay, I want to pop this 50. Pop is nothing but removing an element from the stack. So what it does is it decrements this top. That means this now top will be pointing. It actually meaning what they tell is 50 is been removed and the top is equal to top minus 1 means it will come to 3. Any more top will be 3. When you want to print the stack top, it will be 40. But in array implementation, top will be decremented by top equal to top minus 1, but 50 is actually not removed. But whereas in list, this entire top is also decremented and this element is also being removed. But here actually, while you want to print which element to be is being deleted, then it will be 50. In the pop operation, only top will be decremented to top minus 1 and returns that particular data which you wanted to delete. So in pop, you are going to check whether stack is empty, and then you're going to check whether if stack is not empty, then you're decrementing the top by, for example, here 10, 20 was there, and this is 0 and this is 1. Okay, now I'm doing the pop operation. So while doing pop operation, it checks whether this is empty. This is not empty, so it will come and do the operation of decreasing the value of top by 1. If stack is not empty, assessing the data element at which top is pointing. So this element I'm assessing. So what I'll do for this, I'll make top is equal to top minus 1. Top is equal to top minus 1. Now top was over here. Okay, top was over here. So top value was 1. Top value was 1. So now new top will be 1 minus 1. So what will be 1 minus 1? That is nothing but 0. So any more top will be pointing over here. Okay, and if you want to see which element has to be deleted, you need to just put a printf statement which element was deleted. In array, in the concept of array, top will be decremented while doing the pop and it will be pointing over here. This element will be actually there in the array location. But if you want to insert a new element, right? For example, you want to insert 30. So because since top is pointing over here, anymore it is not pointing over here, this 20 will be replaced and 30 will be placed over here. So that is how the concept works. Okay, the actual meaning is in an array implementation of pop operation, the data element is not actually removed. Instead, top is decremented to a lower position in the stack to point to the next value. But in linked list implementation, it actually removes this also, as well as this will be decremented and it will be stored over here. Is it clear? So this is regarding the two operations. Adding an element onto the stack is push, removing an element from the stack. Okay, so to use a stack efficiently, we need to check the status of the stack as well. So I already told regarding the operations of these is full and is empty. So is full and is empty. So you might have a doubt, what is peak? Peak is nothing but if you want to get the top data element of the stack without removing it, just if you want to find the stack top. Okay, then that is told as peak. That is nothing but regarding the peak function. Okay, so this is regarding the operations of the stack. So in the stack operations, we will be performing push and pop. To use a stack efficiently, we need to check the status of the stack as well. So we'll be going to check functionalities like is full, is empty. So is full, you'll come in which state it is in the push operation. Empty will check in the operations of the pop function. So this is regarding the definition of the stack and the stack operations. Okay, now let us see regarding the laboratory 3 program in the next slide. So laboratory program 3 is based on design, develop and implement a menu driven program in C for the following operations on the stack. So here we are implementing the operations of the stack based on array implementation, and with the max size of the stack we are going to predefine. The operations we are going to do is pushing an element onto the stack, popping an element from the stack, and whatever the stack elements are there, we are going to check whether they are palindrome or not, and then we are printing the status of overflow and underflow. So you know, overflow status is nothing but when you have stack is full, further you cannot do any insertion, then the condition is overflow. So you know where you will check for the overflow status, that is nothing but while you're pushing an element on the stack, if the stack is full, we will actually check. If stack is full, we cannot insert further. So that is the condition of overflow. Underflow is nothing but when you don't have any element on the stack, that is when top is actually equal to -1. That is the situation of the underflow. So these both operations, overflow and underflow, we need to show. And finally, display the status of the stack. Display the status of the stack is nothing but display the contents of the stack, and with the exit function. Support the program with appropriate functions for each of the above operations. So let us see the program now. So what are the header files I'll be using is #include standard io.h. So you already know regarding why we are using for the printf and the scanf. Max, I have defined size as 5, max 5. So for the array, I am declaring int stack max. So the max size is nothing but 5 over here. And you know, if the stack is empty and it does not contain any items in the stack, then top is equal to -1. So that I am declaring. Initially, if you don't have any element in the stack, then top is equal to -1. So this is regarding the header files and the global declarations. So let us go directly to the main, then we'll come back to the functions. Okay, so in the void main, we want to choice so that it has to perform which choice, like whether we have to do the push operation, pop operation, display, or palindrome, or exit. So these are the choices we have. So for that we need to take in choice as int. So while 1, that is nothing but this is an infinite loop, you're going to print the stack operations. So the printf statement will consist of stack operation. Then you have push, pop, display, palindrome, and exit. And then you have print, enter your choice, scanf. So enter your choice. You can, for example, we don't have any element in our stack. Okay, we don't have any element in our stack. So we know that top is actually equal to -1. So here enter your choice. After that, you're taking a choice. For example, let us do the push. We want to enter the choice. We want to push element onto the stack. So I'll read the choice as 1. So switch 1. When I go to switch 1, it will go to the case 1. So what is there in case 1? Case 1 will consist of push function. So it will directly go to the push operation. So what is the job of push? Push operation is nothing but pushing an element onto the stack. So if you remember the definition, what you have told regarding the push operations, you will actually check if your stack is full. If your stack is full, can you do further insertion? If you'll put an if condition. If your stack is full, what is the state? It is actually overflow. That means what? Your stack is full and you cannot insert further. If it is not full, what you can do? If it is not full, what I've told regarding if it is not full, first you'll increment the top by top plus 1. Then on that stack of top, you're going to insert the element. So this is what is happening in the push operation. So now let us take what elements we want to insert. For example, let us take we want to insert 1, 2, 2 and 1. These elements I want to try to insert 1, 2, 1. Okay, so let us do the job. Void push int item. Why this item? Because to read the element of the stack. And then what is the condition I told to check? If top is equal to -1. So what is the initial value of top? It is -1. So that is equal to max size is 5. That is 5 minus 1 is nothing but 4. Whether this is equal, initially your stack does not contain anything. So it was max size was this. Okay, max size was this. So it does not contain anything. So S of instead of stack I wrote S of 0, S of 1, S of 2, S of 3 and S of 4. Initially your stack does not contain any item. So top is actually equal to -1. Top is equal to -1. So if whether this condition satisfies. No, your top is actually -1 and max -1 is nothing but when the stack, if top is 4 and then your max -4, this is also 4, then you know stack overflow condition occurs. Now you don't have any elements on this stack, so it will obviously, this condition doesn't work, it will not go within this, so it will go for the else part. So in the else part, whatever the element I want to insert, for example my first element I want to insert is 1, so enter the element to be pushed. So I will read the element 1. This is nothing but since it is item is an integer, format specifies %d, address is an item, pushing element onto the top of the stack. So what you have to do first, see here, when you insert an element 1 over here, you know that top will be pointing over here. So what is the first step you need to do? First you have to increment the top, then you have to insert the item into the element. So this statement meaning is nothing but top should be incremented first. Top is equal to top plus 1. Then that stack of top you're going to put your item. So what is your top now? Top is nothing but your initial top is nothing but -1. So -1 plus 1 is nothing but 0. So what will be here? Stack top is stack of 0, you're placing the item. So what is the stack of 0? 1. So you place the 1. So that is nothing but the meaning of this particular statement is this itself. Increment the top is equal to top plus 1. So -1 plus 1 will be 0 and the top value is updated to 0. Now stack of 0 will be nothing but consisting of the item. Item is nothing but the 1. Similarly, if I want to push 2, 2, 1 same way, now your top value will be updated to, I'll write here, updated to 0. We'll check whether 0 is equal to 4. No, it is not equal to 4. So again it will come to the else section. So what will happen? Again enter the item to be pushed. So next item I want to push is 2. So again here it will be top is equal to top. Now your updated top value is what? Top, again top is equal to, your updated top value is 0, because in the, now you're checking here, see updated top value we got as 0. You can see here stack top value is 0. 0 plus 1 is nothing but 1 and stack of 1 you're placing the element. Stack of 1 you're placing the element. What is your element? 2. So then you're placing 2 over here. Similarly, all these elements I need to push, same operation. Top will be, all these operations I need to push. So again it will be 2, again top will be over here, next again 2 and last again, now your top value is 3. So let us see that condition also, where you check for 3 is equal to 4. It's not equal, so it will come to else part. So in the 3 I actually want to insert this 2, right? Yeah, insert this 2. So I'll read this particular 2. Now your top value was 3. Top value is 3. Yeah, top value is 3. Okay, so top value is 3. You're going to insert 1 actually. Top value is 3. Next you're going to see that 3 is equal to 4. No, it is not equal. We have inserted these many items. Last item I want to insert. So what will happen? Top value is 3. So again top will be nothing but 3 plus 1. Top plus 1. That is nothing but 4. So stack of 4, the updated value will be nothing but 1. So this 1 I'll be pushing over here and again the top will be here. Now check the value of top. Top is equal to 4. So now 4 is equal to 4. So stack overflow status. So this is regarding the push operation. So this is regarding the push operation. So let us see regarding, once you have done the push, let us see regarding display status, because once you have pushed the element onto the stack, let us see regarding the display the contents of the stack of 1, then you push 2, then again you push 2, then again you push 2 and then again you pushed 1. So you know that this is stack of 0 and this is 1, stack of 1, this is 2 and this is 3 and this is 4. So these many elements I need to push. Okay, I need to push. So in case if your stack is empty, does not have anything, then what is the condition? If when your stack is empty, only if top is equal to -1. If this is the condition, stack is empty. If not, else what is the condition? There must be some contents in the stack, right? So those elements let us print. So that's why we are written here. If top is equal to -1, and sorry, stack is empty, else the elements of the stack are. So for loop, from where I have to print whichever. So this way itself I need to print, right? That is from top, because you know the top element will be popped first, the last element will be popped last. Okay, so I need to display in this order itself. So what, from where I need to read? From top itself. So for I is equal to top, for I is equal to top, that is I is equal to 4, then 4 greater than or equal to 0, yes, it is true. If it is so, I need to print stack of I is equal to what is the element in that particular stack. So that is nothing but actually stack of I, in the sense this is the printf statement. Okay, don't get confused. This is a printf statement stack, whatever is getting printed. What is the value in I? That is 4. Stack of I value is 4. So this 4 within this bracket percentage d, 4 will be printed, is equal to percentage d is nothing but stack of I. What is the content of stack of I? Stack of 4 is having what? So 1 will be displayed. So stack of 4 is equal to 1. This is how it will get displayed. Then I will be decremented. So now I value is 3. Similarly for I3, 3 is greater than or equal to 0. You will check yes, it is true. If it is so, printf. This stack will be printed as it is, stack of stack. And what is this percentage d? This percentage d is what is there in the value of I. So that is nothing but stack of 3, and this equal to percentage d is what is there in the content of the stack of that particular stack of 3. So that is nothing but stack of I. We directly write stack of I means directly element will be printed of that particular stack of 3. So what is there in stack of 3? 2. So similarly it will go on again decrement. I will be 2. Again you will check 2 greater than or equal to 0, true. Then again stack of 2 will be printed. What is there in stack of 2? Again 2. Similarly I will be decrementing. Now I is 1 greater than or equal to 0, you'll check, and then again you will be printing stack of 1. That is nothing but stack of 1 is what? Again 2. Then again I will be decrementing. Now I is 0 is greater than or equal to 0, you'll check, it is true, and then again stack of 0 is having the value 1. So this will be printed over there. So this will be printed over there. Okay, so this is regarding the display statements. In case if it does not have any elements on the stack, then your stack is empty. So this is regarding the display of the status of the stack. Now let us give the, like you have done the push operation. Once you have done the push operation, you have displayed the contents of the stack. So let us try to pop the elements from the stack. So what you have to enter the choice 3. So it will go to switch 3. So it will go to the, enter the pop operation, case is 2, switch 2, it will go to the case 2 pop. So let us go to the pop function. So in the pop operation, what I have told in that, in case if your stack does not have any element, can we pop? No. So you need to check if top is equal to -1, stack underflow, because I cannot pop any element. Else what can I do? Else I just need to, I've told in the pop operation, you're just going to decrement top -1. Top is equal to top -1. Okay, only this one operation you're going to do. So we had actually in a stack, we had 1, 2, 2 and 1. Okay, so you know that this was 0, 1, 2, 3 and 4. Okay, so popping is also at the top end. So you know the stack definition, last in first out. Okay, so you'll check if your stack is empty, if that means if top is equal to -1. If it is so, I cannot do any pop operation because I don't have any content in the stack, so it is stack underflow. Else I need to pop the element from the top, right? So this will be actually meaning is this will be popped. That is nothing but top is decremented by top -1. So your this has been popped, top will be pointing over here. So what is the meaning here? Remember in array implementation, actually top will be getting decremented by 1 and the top will be pointing over here. Now no more it will be pointing over here. This content will be there, it will be not deleted. Okay, only in list top also will be decremented and the content of that particular stack element also will be deleted. Okay, whereas over here, in case next if you want to try to push some element, then this one will be replaced by that particular element and the top should be decremented, right? So incremented, top will be incremented by 1 position and next element will be 1 will be replaced by whatever new element is being done. So remember this concept. While popping, just top will be decremented. Okay, top will be decremented. So if you want to know which element was being popped, then you just need to put the printf statement of which top element was popped. That's it. Okay, so let us see. So if top is equal to -1, we don't have that such state. So in our case it is else part. So it is not stack is full actually, so it will come to this particular else part. So printf popped element is %d. If you want to know which element was actually popped, that you need to do the you need to print f, right? So you need to print that particular element. That's why I've written popped element is %d stack of top minus minus. So what is this step actually? It is nothing but it will display what was there in stack top. What was there in stack top? So what is there in stack top? That is stack of 4, 1. It will display that one value, what is there in one value, and then for next iteration top will be decremented by top minus 1. So where your top will be pointing now? 3. Anymore it is not in 4th location, but content what was popped, right, that will be displayed as 1, stack of 4. So you know that what is the job of post increment. First, what is the job of this post increment? So the top value will remain same. Later for the next iteration top will be decremented by 1. So this is the operation of the popping. So similarly, if I want to pop 2, next what will be the popped element is %d, that is stack top will be now what is there in stack top? Your top was 3, right? Next iteration, so 3 is 2. Then top will be top minus 1. So what is top minus 1? 3 minus 1, so it is 2. So now top will be pointing over here. So this is regarding the popping an element from the stack. So similarly, you can pop all the element. If you pop all the element, your top will be equal to minus 1. So here when it comes to minus 1, then stack will be underflow. That means there is no content in the stack. So this is regarding the pop function. Now let us go again back over here. So we have seen regarding the push, pop and display. Now fourth one is regarding the checking the content of the stack, whether they are palindrome or not. So you know already the concept of what is palindrome. If a number is written in such a pattern like 1 to 1, the reverse of this should be the same. Reverse of a number should be the same. So this is regarding the palindrome. So let us check the palindrome status. Okay, so let us assume that our stack contains now 1, 2 and 1. Let us assume that now our stack has 1 to 1. So this is stack of 0, this is stack of 1, this is stack of 2. Okay, S of 0, S of 1, S of 2. Now over here we need I and counter. Counter is to check this count variable I'm using to check whether they are palindrome or not. So initially counter is set to 0. After that, for I equal to 0. So for I equal to 0, initially I'm taking I equal to 0 and I less than or equal to top by 2. What is our top now? Top value is having 2, right? Top value is 2. So I is less than or 2 by 2. That is nothing but 1. Yes, so you know I is 0, 0 is less than or equal to 1. This is true. If it is true, you will see if stack of I, what is there in stack of I? Stack of I is what? Stack of I is stack of 0. What is there in 0? That is stack of 0. We are going to check if stack of 0 is equal to stack of top minus I. What is value of top? 2 minus 0. Okay, so what is there in stack of 0? 1. What is there in stack of 2? Stack of 2 is also 1. Whether they both are equal? Yes, both are equal. Then count will be incremented and is equal to 1. Next iteration I will be incremented. So I value will be 1 now. This I has to be incremented. So I value is 1. So you know 1 is less than again equal to 1. This is also true. If it is true, you will check for stack of again if stack of 1 whether that is equal to stack of top minus 1. So that is again stack of 1 itself. Stack of 1 itself. Top value was 2 and minus I value was 1. So this is stack of 1 itself. So you know that stack of 1 and this side also 2 is equal to 2. Now counter will be incremented to 2. Now what is happening? Again you will increment the I value. I will be 2 but 2 less than or equal to 1 fails. So this will come out of this particular loop. Next you will check if top by 2 plus 1, that is nothing but you know top value is 2. If 2 by 2 is 1 itself plus 1, that is nothing but 2 itself. If that is equal to count, what is our count value? Count value we got it as 2. If that is the case, then stack contents are palindrome, else stack contents are not palindrome. Is it clear? So this is regarding how the stack can be checked whether they are palindrome or not. So this is the status of the palindrome. Okay, so in the void main we had read the push, we have gone through the push operation, pop operation, display, palindrome, and then finally if you want to come out of this particular main function, we use this return exits function, and in case for default we have given the invalid choice. So this is the explanation of the logic of the program. So demonstration of this particular program, let us see in the code blocks. Now let us see the execution of the stack program. Let us run this particular program. So control save, and you can use a build and run. If you already saved this particular program, you can just run the program. So let us run this particular program. So what were the stack operations we had already seen? Push. So what we have explained in the program, same integers let us try to insert. So I'll click on the choice 1, push operation, enter the element to be pushed. First element I'll be pushing 1. Again I'll click on the push and enter the element to be pushed is 2. Again 1. Then I'll give 2. Again I'll be inserting the element 2. So I'll click on the 1, push operation, again 2. So totally 4 elements I've inserted into the stack. 1, 2, 2, 1. Again I'll be inserting one more element, that is 1. Now 5 elements have been inserted. Further, if you try to insert, you will get the status as stack overflow because our max size of stack is only 5. So 6th element what I tried to insert is not possible. Stack overflow status is being displayed. Now display the contents of the stack. So you have stack 4 is equal to 1, 3, 2. So these are the stack elements. Now try to do the pop operation. So click on 2. So the popped element is 1. Similarly, try to pop all the elements to check the empty status. So enter your choice 2 again. So stacked popped element is 2, again 2. So again popped element is 2, again 2, popped element is 2, and then again click on 2, popped element is 1. Now all the elements of the stack is been popped. Now when you give again pop operation, what it will give? Underflow status. So you know that you don't have any element in the stack, so stack underflow. You cannot pop further in the stack. Next you give the display. When you give the display status, what will be there? You don't have any element, so stack is empty. Sorry, empty stack. So it's seen the push operation as well as pop operation and display of the stack. Now we need to check regarding the palindrome. So before we check the palindrome, we should have some content in the stack. So let us push the contents again into the stack, that is element into the stack. So I'll give 1. So let me push 1, again 1, let me push 2, again 1, I pushed 1. Now display the contents of the stack. You have 1 to 1. You know these are actually palindromes. So 1 to 1, when you do reverse, again it is a palindrome. So check for palindrome status. 4 stack contents are palindrome. So you're checked. Now check it for stack contents are not palindrome also. So again you insert one element, that is 1. So again display 3. So 1, 1, 2, 1. Now check for the palindrome status. You know that stack contents are not palindrome. So in the stack program, you need to check for the overflow, underflow, as well as the empty status. And then you need to check for whether the contents are palindrome and the contents are not palindrome. So this is the execution of the lab 3 program, that is based on the stack operations. Thank you.